Happy Thursday. It's Thursday, 26th of December. And today I'm going to be recording video on DeepCode AI. I have one video already. This is the second one. So the difference between the first one and the second one is that I'm going to be talking more about the capabilities of DeepCode AI to analyze polymorphic malware. And another reason is that this is DeepCode AI. If you're not familiar with their webpage, I was looking at a demo on how to do it in preparation for a course that I'm going to have to deliver. So this is a 4-hour course that I need to deliver with O'Reilly. If your company has a subscription, please join in. It's going to be on the 3rd of January, and there's still some slots left. But I was looking at how to explain what Snyk does. Basically, DeepCode AI was acquired by Snyk, so now DeepCode and AI and Snyk are the same thing. And they just recorded this demo, so you have to log in with your professional email, and I thought it's going to be very informative, but it isn't. So that is a second reason why I'm recording this video, because the demo that they have, it just tells you how they're going to use machine learning, but it doesn't tell you what type of machine learning they're going to be using. The demo tells you what the tool can do. It doesn't tell you how it does it. So everything it's not a black box, but they're not focused on explaining the details of the steps that the tool is taking. They're focused on very commercial aspects of explaining how the product works. And you can see that because the demo, you won't be able to watch it with your Google email account. You have to register with a professional. So I had to register with my University of Oxford account in order to watch the demo. And when I watched the demo, it didn't explain to me the basic things that I wanted to know. And I'm going to show you what I wanted to know. This is uh, the PowerPoint presentation. It's not a PowerPoint, it's a whiteboard presentation that I prepared. So I'm going to shift from the computer to the iPad and I'm going to explain it with those 4 slides. Actually, I have another 5 slides, and I'm going to be drawing to explain which machine learning tool it's using and how the process operates. So this is going to be a video about the process, not so much on the final result, because as you can see, they have already recorded videos on the final result. If you're interested in this kind of content, please subscribe if you haven't already to my YouTube channel. I need more subscribers. Subscription is free and it's going to remain free. There's no intention of to charge. I actually have a job. I earn money for a living. If you don't know me, let me just show you. That's me. I work for the University of Oxford. You can check my work profiles or my Google Scholar citations. If you click the link, it will show you that I work for the Department of Computer Science, and it's going to talk a little bit about my interests. So this is the most important part, that I work in AI security, post-quantum cryptography, blockchain security, and other areas. Um, so that's enough about me. Final thing, if you want to read some of those papers that are published, they're completely free as well. So you click open and it's going to open the paper. University of Oxford paid the open access fees, around 3,000 for each one of those links, for them to be available to the general audience. So they are not locked. When you click, it's not going to ask you to subscribe to a journal or something else. Snook, on the other hand, it's a program that you need to pay for. So I'm gonna explain what it does and how it does it. So technically they should be paying me for this, but this is not a promoted video. I have no association with them. Nobody has ever paid me to do a YouTube video. The reason why I'm doing it again, because it's going to be part of this course that I'm doing. I'm going to have 8 segments. So I have like those segments. And for each segment, I'm going to have an exercise. So it's going to be like an example of an activity at the end. So Deep Code AI is going to be one of the activities that I'm going to show for 10 minutes. And that's the reason why I'm recording the video, not for any promotion or any kind of form. So please subscribe to the AI School Oxford channel if you haven't subscribed already, and click the like button. Or if you're interested in how to make money from cryptocurrencies by testing new projects and earning the cryptocurrencies for free, so there's no actual money involved in most of those, you can subscribe to my Crypto School Oxford channel. And now I'm gonna move on to the whiteboard. So starting from the basic, what is Snyk, what is deep code, and why do you need Snyk and deep code? Well, as a in most of the jobs now we have to do some kind of a code writing, and most people think that it's just about writing code of text, but actually it's more about this. It's about writing secure and reliable code. So there's no point writing code without knowing that there are vulnerabilities that you're using. And according to some statistic, most of the code that we write is copied and pasted from somewhere. So between 85 and 95% of the code that we take is just snippets that we copy and paste from GitHub and other repositories. So the problem is that sometimes there's vulnerabilities in the code itself, there's vulnerabilities in the dependencies, there's vulnerabilities in the containers, and there's vulnerabilities in IACs. So there's various different vulnerabilities that you're trying to avoid, and constantly checking that manually, it's extremely difficult. That's why we have automated the process. And Snyk and these various other tools that we're going to discuss in other videos are techniques that you can use, that you can integrate in your code writing file, and it's gonna detect automatically if there's any vulnerabilities. It's also gonna be updating the scan on regular basis, so if there are new vulnerabilities detected in the code or in the dependencies or in the container or in the IAC, then Snyk will notify you. So you can actually enable push notifications that is gonna tell you on your Slack channel, or actually I get emails from Snyk as well. So I get emails to my Gmail, and it tells me when the scan has failed, when specific vulnerabilities has been detected. So that's what Snyk is, and I'm not saying it's the best tool that is available on the market. Clearly, it's a commercial product, and there's various other tools that you can use, but the world is kind of shifting slower and slower towards the AI managed risk of cyber vulnerabilities. So this there's still human in the loop, but it's becoming more and more difficult when you copy and paste code to detect vulnerabilities that they are specifically if they are in the dependency or in the container. So that's what Snyk is, and what we have prepared for today is that we're going to talk about static analysis with DeepCode AI, how you can even reverse engineer polymorphic malware using this static analysis. So clearly, Snyk is not designed for that specific purpose, and I wanted to add a twist because I wanted the video to be different than the demos that they have. Clearly, I don't want to be associated with a commercial product. I don't want you to think that I'm promoting this product in any way. I use all of the products that are available on the market, all of them. So there's not a single product that I don't use, and each tool has its purpose. So it's the same like a plumber doesn't go to fix a job with one tool. It goes with a whole set of tools. That's why they have a van, because they have to carry different tools. And you need to understand how it works. Clearly, the demos that I watched, they didn't really explain the things that I want about the types of models, the language support, for example. Actually, language support is included somewhere, but I wanted to know about the dataset and how they use variation of autoencoders, and that was not clear in the description. So I had to do a lot of digging, and some of the information that I can provide is possible that is not even correct because it's a result of my research, and obviously research it's sometimes requires to be checked. So I'm going to be constantly checking my research, but this is so far what I have discovered from reading the files that they have and their code and how the DeepCode AI operates. So first, let's start with what we know for certain. What is DeepCode? DeepCode AI is an analysis tool for models and datasets. So with DeepCode AI, it's a one tool that integrates machine learning with symbolic reasoning to detect vulnerabilities. But not only vulnerabilities, but also malicious patterns and logical inconsistencies in the code. So here I can include those details. So how many there are? There's 1, 2, 3, 4, 5. So those 5 would be on the first slide. I'm going to discuss those, and I'm going to move to the other slide. I have 4 slides in total on DeepCode AI and Snyk, and by the end of the fourth slide, hopefully you're gonna know more about Snyk than the engineers that they developed the product. But let's start with what is it? It's a hybrid AI model. So DeepCode AI employs a combination of symbolic AI and generative AI. So here we have two. First is symbolic, and second is generative. Um, and the symbolic AI uses predefined rules to identify known vulnerabilities and code patterns. With then the generative AI uses more advanced architectures, just fine-tuned transformers. And why is it using those fine-tuned transformers? It's using them to predict and to synthesize potential vulnerabilities based on the code logic. And now, this kind of explains why there's actually a dollar cost associated with this product, because transformers usually you connect to them through an API and they charge you. So there's always going to be a cost with this until the technology matures to the level that it's free and open source. But that's going to take a little while. Remember that the transformer models, so where generative AI is based on the transformer model, the very first paper on the transformer model came in 2017 by a group of Google researchers. So they were at Google at the time, and then they shifted, and many of them they have their own companies now. But then OpenAI created ChatGPT, the first transformer model. But actually, the very first paper was in 2017. I finished my PhD, my Viva was in 2013. So if I didn't continue studying and learning, I wouldn't even know what is a transformer model. But so that is the first thing covered. The second one is, well, actually, let's talk a little bit more about these hybrid models, because it's not only I spoke about Google and OpenAI, but actually the models here that are employed are more like BERT. And what does BERT stand for? It stands for bidirectional encoder representations from transformers. So I think the actual variant that they use is probably the code BERT. And CodeBird is probably adapted to understand the syntax and the semantics of the programming languages. So those generative AI models usually are trained on large data sets, and they can build understanding on programming patterns and common coding practices. So basically, it's taking that knowledge from the entire world and it's putting it in combination with the symbolic AI, which is basically AI that it does not require to have a connection to an API. It's just there. It's more like it's a different form of AI. But now let's move on to the graph neural networks, which we have over here. That's in point 2. DeepCode AI uses graph neural networks to model the relationships between various code components, such as functions, dependencies, and control flows. So by constructing a code graph, it identifies how different parts of the code interact and highlight anomalies. So, for example, polymorphic malware often introduces deceptive function calls or modifies the control flow to conceal its true intent. That's how it tries to trick you. But then graph neural networks can detect those irregularities by tracing the execution path and identifying deviations from the normal patterns. So this is most probably what they use, done from the research that I've done, looking at the code that they have and their open access information that they provide. So you have to look very deep to identify those specifics about the how it operates. And that's the second done. Let's move to the third one, variational autoencoders. Variational autoencoders are used for anomaly detection by establishing a baseline of normal coding behaviors. And those are trained on datasets like GitHub's open source repositories, and they can identify deviations from expected patterns, such as extensive aliasing, so nested logic, or unusual obfuscation techniques. So that is how variational encoders work. So that's the third one, and moving to the fourth one, which is quite important actually, the datasets. What kind of datasets does it use? First is GitHub Code Corpus, and this is where millions of permissibly licensed open source repositories are used to train the models on secure coding practices. And this provides a baseline for detecting abnormalities. So that is the first one. And the second one is the NVD, National Vulnerability Database. So it's cross-referencing the GitHub code corpus with the NVD to identify known vulnerabilities and to enable the tool to pinpoint exploitable weaknesses in the analyzed code. Third and the final that I found is the Ember dataset. And this is a specialized malware analysis dataset that is used to train DeepCodeAI models to recognize malicious patterns and behaviors. So this one basically has three datasets. So the first one is the GitHub Code Corpus, second is the National Vulnerability Database, and third is the Ember dataset. So there we are, we have the fourth one covered. And the fifth here, language support. What kind of language does it support, DeepCodeAI? Actually, this is information that you can find relatively easy on their webpage. DeepCodeAI supports around 19 programming languages, including Python, Java, JavaScript, C++, and Ruby. And so it's quite widely available, and this makes sure that if you're using it, you're going to have a coverage for analyzing polymorphic malware across different code bases. So let's move to the next one now, slowly. In terms of advanced features in malware analysis, Snyk, or actually DeepCodeAI, so when we say Snyk, DeepCodeAI and Snyk are the same now. Snyk acquired DeepCodeAI. Snyk is primarily a tool for securing dependencies, so containers, APIs. It has advanced features that make it, quite a useful addition to the static analysis workflow. So we're going to talk about the following 4 different key points that I think are very important in order to understand how Snyk operates. So the first one, the dependency analysis. Snyk can scan third-party libraries and open source dependencies to identify vulnerabilities. And many polymorphic malware strains exploit outdated libraries to gain initial access to execute payloads. And Snyk integrates this with the CVE database to pinpoint such vulnerabilities with quite a good precision for a static analysis tool. And in terms of, so first one is done. The second, in terms of container security, malware usually operates within the containerized environment, so such as Docker or Kubernetes. So Snyk provides a layered analysis of these environments, and it helps with detecting misconfigurations. And not only misconfigurations, but also embedded payloads, outdated software components, and other things that can be used and exploited by the malware. But mostly it's scanning containerized environment like Docker and Kubernetes and provides a layer analysis. And then the third one, the custom rule development. Snyk enables you to create custom detection rules that are specific to malware patterns. So for example, if a strain of polymorphic malware is known to use a very specific obfuscation technique, a custom rule can be developed to flag instances of this behavior in code bases or dependencies. And then moving on to the final one, the fourth one, Snyk and DeepCode. So here we use Snyk, here we use DeepCode, is the same. I guess eventually at some point they're going to merge into one name. But DeepCode AI works in tandem to, both of them, they work in tandem to provide a holistic analysis. So DeepCode AI focuses on the code base itself, and Snyk extends its analysis to the broader software ecosystems. So Snyk is identifying vulnerabilities in external dependencies, containers, and APIs. So they work together. But DeepCode AI is mostly for code, and Snyk is for everything else. But they're kind of the same thing. I guess Snyk was a little bit weak in terms of code development. That's why they thought it's beneficial for them to acquire DeepCode AI. Now, let's look at how to reverse engineer. And again, this is conceptual, just to remind you that nothing here is teaching you how to build malware. Most of the information that I'm going to provide, we actually teach in a university setting. And malware by default is software. So it's a software designed to do bad things. And that's what it is. It's nothing really specific about malware, it's just software. So polymorphic malware, such as, let's say, Black Mamba, which we spoke about Black Mamba in one of the other videos. It's a proof of concept polymorphic AI based malware that changes every time that it attacks, changes the code. So Black Mamba dynamically changes the structure of its code base to evade detection mechanisms. So it's combining the capabilities of Code AI and Snyk would enable you to effectively reverse engineer it by analyzing the different attack patterns. And remember, because it's a proof of concept, you can containerize it and just run that over and over again until you identify a pattern on how it works. So this strategy can be developed not only to analyze and understand, but also to combat other threats. And that's why we built things like Black Mamba, the proof of concept malwares, just so we know how adversaries can build it, and then we can test it in a controlled environment and set up prevention mechanisms for it. But let's go into step by step on how you would reverse engineer polymorphic malware like Black Mamba. So first you need to extract the code. This is the code isolation. You have to extract the malware sample and place it in a secure isolated environment. And you need to ensure that the sample is free from encryption or runtime protection techniques, because those could obstruct the static analysis. And what would be the purpose? So if that is the objective, what would be the purpose? It would be to ensure that a controlled environment, you can analyze the malware in a controlled environment without risking further infection. So it's not only about analyzing code, it's about protecting other infrastructure. And the steps that you would need to apply, so here we have 4 steps. So the first step is that you need to create a secure sandbox environment with tools like Cuckoo. So let me just write this. Cuckoo Sandbox, or any other dedicated malware analysis system. And the second step would be to extract the malware sample to ensure that the encryption layers, for example IES or RSA wrappers, are removed using tools like PAID. You can use those to extract the encryptions from IES or RSA. And what does it stand for? PAID? It's a portable executable identifier. Or you can use IDAPRO. Many people prefer to use IDAPRO. Hold on, let me zoom in a little bit because I'm gonna run out of space over there. So that's the first one is covered. So we have covered that, and let's move to the second one. the initial code analysis, you can use DeepCode AI to perform semantic analysis of the code base. So this is a hybrid AI models that will identify obfuscation techniques such as junk code insertion or control flow randomization. So Snyk can scan the dependency tree to detect any third-party libraries or frameworks that the malware uses for execution. And what is the purpose of that first step is to gain the initial understanding of the malware structure and the behavior without executing the code. So that is why you perform the semantic analysis on the code base. And what are the steps that you would employ? So here we have two steps. So the first step is you can apply the deep code AI to perform detailed semantic analysis of the malware code, and these steps focuses on identifying the obfuscation techniques, junk code, redundant functions, and control flow. But what is an example of this? So we already said that. The example is that deep code AI would use symbolic reasoning. So let me symbolic reasoning, in case my accent is and my pronunciation makes it difficult to understand, but that is a technique that we apply to highlight suspicious loops or recursive structures, and often is inserted into to mislead detection algorithms. So that is the first step. And the second step that you could apply is to run Snyk to analyze the malware dependency tree. So this involves identifying external libraries or APIs that the malware relies on, which could reveal key operational dependencies. So for instance, detecting the use of outdated OpenSSL libraries could indicate potential entry points for payout delivery. So that's the that's the second step done. And moving to the third step, data flow tracing. So for this step, the deep code GNN map, the flow of data through the malware code, this would help the analysis to reveal how the malware manipulates data. So identifies the injection points and highlights suspicious API calls. So this it's usually done. The purpose of this kind of analysis when you're running the GNN map to map the flow of data through the malware code. This is usually done to understand how the malware manipulates and transfers data, which is how usually it's done to uncover injection points in exfiltration systems. And what are the steps that you need to perform to complete this, the third step? You can use deep code AI graph neural network, so that's the GNN, to create the data flow graph of the malware operation. And this maps the movement of the data through variables, functions, and memory locations. And one example of this first step is to identify how sensitive users' credentials are captured by the malware and where they redirected for exfiltration. And the second step would be to highlight abnormal behaviors, such as the use of hard-coded IP addresses or API calls to external server, because remember, polymorphic means that it has to call API in order to change its code. So if you can detect that such behavior, this could indicate the command and control communication, which is usually written C2. Why is command and control written as C2 communication? I have no idea. Somebody just thought that C2, it's a good example for that abbreviation, and you can see it quite often. C2 stands for command and control communication. And now, since we have completed the third step, let's move to the fourth step of the process. So the deep code AI, the variational autoencoders, can be applied. So variational autoencoders can reconstruct the original logic of the obfuscated code by identifying invariant components. So those are things that can remain consistent across multiple iterations of the malware. And what is the purpose of that? The reconstructing the variational autoencoders. It's to uncover the original logic and the intent of the malware. So once it's obstructed by obfuscation techniques, you can uncover the original logic. And what are the steps, which is more important? What steps do you need to take? Well, here we have three different steps. So first, you can use the deep code AI variational autoencoders to detect invariant code components, and these are portions of the malware that remain unchanged across different polymorphic iterations. So you can detect things that they remain the same. And that could reveal its core functionality because remember, it tries to achieve something, and some part of the malware will remain the same. And one example of how that could look like is that the malware, for example, control flow may be scrambles, and the core functions such as keystroke logging or the data exfiltration could exhibit consistent patterns. And what does it mean is that the keystroke logging is required to capture your password, and then the data exfiltration would always be, those two steps would be always repeated. So the keystone action and the data exfiltration, and because you need to know what the person is typing in order to read his password, and then obviously after you have secured that, you need to send it somewhere, and usually that's done. Actually, with Black Mamba we've done it with Teams, and Teams is very popular app on Microsoft. Most people think that Zoom is easier to exploit, possibly, maybe. We've done it with Teams. So that is the first step. And then the second step is so that's the first, and the second step is to employ deobfuscation techniques, such as this one, OLLVM, which stands for Obfuscator LLVMs, or in other words, it's a custom script to remove additional layers or code wrapping or function inclining. And the third step that you need to do is to compare the reconstructed code against known benign and malicious patterns to differentiate between deceptive and actual code segments. Now that is the fourth step done, and now we are moving towards the fifth step, the API monitoring. Well, DeepCode AI would flag unusual API calls. So those that, such as for example from large language models, OpenAI or GPT-based APIs. So DeepCode AI would monitor those calls, those calls to understand how the malware generates new code or executes payloads. So what is the purpose of this? Is to identify the malware use of external services, so specifically the code generation or the payload execution. And in terms of steps, so we have here three steps that need to be performed. And the first one is to analyze the API calls that would be flagged by DeepCode AI for unusual behavior, such as requests to large language models APIs, and those calls would be used to generate malicious code on the fly. So that's what makes it polymorphic. That needs to happen. And to how do you monitor LLM APIs? You monitor prompts sent to ChatGPT based APIs to understand the instructions given for synthesizing key logging or encryption function. So that is one way to detect it. Second way is to use network monitoring tools like Wireshark or Zeek to capture and analyze outbound API traffic and to align with legitimate usage patterns. So that would be the second step to eliminate normal usage. And third would be to correlate API usage with the malware operational timeline to identify when and how dynamic code generation occurs. So that is the fifth step done. And now moving to the sixth step, cross-referencing with threat intelligence. So here, what does it happen at this step? At this step, the tool is correlating findings from DeepCode and Snyk with threat intelligence databases like VirusTotal. So it's correlating the findings, and this step helps attribute the malware to known families or to identify new variants. So the purpose is to attribute the malware to known families and to detect novel variants. So that is the purpose of this step. But now, how is it done? How many steps do you need to perform to achieve that? So let's look at the 3 steps again that you need to do. First is you need to compare findings against threat intelligent databases. So not only VirusTotal, but you can also use MITRE ATT&CK. Or even Ember. So you can use any one of those 3. Just an example of how it does it, it uses cross-referencing malware hashes or behavioral signatures to reveal similarities with previously unidentified threats. So that's the first step. The second step is to identify zero-day characteristics by focusing on behaviors or code structures that they are not documented in existing threat intelligence repositories. And the third step that it does is to generate a detailed report summarizing the malware tactics, techniques, and procedures. So those are usually written like TTPs. Actually, that's in the third step for sharing with cybersecurity teams. And that is actually all that is done on the 6th step. And the 7th and the final step of this slide before we move to the 3rd slide, 3 out of 4 slides, is the custom rules for future directions. So you can use Snyk to create custom rules based on the analyzed malware behavior. And this ensures that the proactive detections of similar threat in the future. And the purpose of that step here is to enhance proactive detection and mitigation of similar threats that they would come up in the future. And here again we have 3 steps. So now I have a little bit more space here to write. But what is the first one? Is that you create custom rules using Snyk to flag specific behaviors or patterns, identifying during the analysis. And one example here is that rules targeting the use of polymorphic code, the templates or frequent API calls to trusted but exploited platforms like GitHub or Slack. So that would be the first example, that you would create a rule targeting the use of polymorphic code templates or very frequent API calls from platforms like GitHub or Slack. And second is to incorporate these rules into automated scanning tools to ensure that the future iteration of the malware are detected early in the development cycle. And the third step is to validate the rules by testing them against known benign and malicious samples to minimize false positives. Now, how far did we get on this? Well, we are at the final slide actually. So we're at the conclusions, the limitations and considerations. So before I get into the conclusion, let's look at the limitations and consideration, and then we're going to end this video because it's going to get too long, and I'll record another video on different tools. Again, there's so many different tools, and Snyk and DeepCodeAI are just one tool. So hopefully in this video I have explained things that they have failed to explain. Why? Because it's a commercial product and they focus on what kind of value-driven propositions they have, as opposed to talking things that only the developers would understand. So most of that knowledge is not, most of the knowledge from this presentation is not required for a simple user who just wants to click the button. This is a knowledge that is required for somebody who wants to know how this system works. But what is the limitation and consideration before you YOLO into subscribing now because you know these good things about the program? Well, they both DeepCode and Snyk offer very strong static analysis capabilities, but they have limitations in the runtime behavior and the encryption techniques. So let's start with the first one. Polymorphic malware often exhibits behaviors that are only manifested during execution. And static analysis by default, so we have static, then we have dynamic, and then we have hybrid. So DeepCodeAI and Snyk belong to the first one, static analysis. And static analysis needs to be complemented with dynamic analysis to capture these activities. And the second one is the encryption techniques, where malware that encrypts its payloads can evade this static analysis. So tools such as sandboxed environments and runtime monitors are important for addressing this specific limitation. And what's the conclusion on DeepCode AI and Snyk to end the video? Well, they're very good tools. They have strong capabilities for this static analysis. And they use machine learning models, the ones that we discussed in previous slides. So that's the definition that they include. We use machine learning models. They don't tell you what. So previous slides explain all that. An extensive data set, that is another very vague definition that they have. So in previous slides, I explained which specific data sets, and they're integrating those into threat intelligence. So if you follow the step-by-step guide, you can effectively reverse engineer polymorphic malware, and you can develop strategies to mitigate future threats. So you can develop, using that knowledge from this analysis, you can build your own Black Mamba code. Actually, that's how we build the Black Mamba polymorphic AI malware. So Black Mamba is built by a researcher, and in some of the other videos, I'm going to be talking about Black Mamba 2.0. Because remember, Black Mamba was written in 2023, and now we're reaching 2025 in a couple of days. So it's been 2 years since that code was developed. So now we're going to have 2.0 version that I'm going to talk on the presentation that I have on the 3rd of January 2025. And you can use those Black Mamba type of polymorphic AI malware to uncover operational details and design effective countermeasures. So basically, you can see how what you've learned from the static analysis, develop a code, run that, and see if you can detect that kind of malware easier. But you need a more general approach that you would combine static and dynamic analysis to counter this landscape of growing AI-powered malware. And that's where even the hybrid analysis is probably the future, because dynamic analysis is definitely stronger in some areas and static analysis better in different areas. So you need to have a combination of both, not just one. I think that's enough on this one, because if I extend it too long, it's going to get really tedious. But this is the whole presentation. That's all that we covered. So we have 1, 2, 3, 4, and the fifth one was the concluding slide. 5 slides to explain how Snyk and DeepCodeAI operates. Consider subscribing to the channel if you haven't subscribed already. It does help motivate me write and create these videos. Again, this is going to be a much longer video. It's going to be 4 hours tutorial with O'Reilly on 3rd of January 2025. So you can find that on O'Reilly's webpage. Just type my surname, which is Radan Liev, and you can attend that 4 hour session if your company has access to their digital library. Most large companies and universities have free access to O'Reilly Digital Library, and people don't even know. But this is basically my preparation for that very long video, 4 hours. This would be 10 minutes. So you see, you have to go through this to see how long it's going to take you. And talking to the mirror is not my thing, so I prefer to do it on YouTube. Um, but it's my preparation basically. In any case, it's free, and my channel it will remain free forever. So consider subscribing to support this idea of sharing free knowledge. See you in the next one.